Welcome to Ask and Learn.
So the question about the lunar landing here, and in this problem, we have the lunar module. Okay, so this is the lunar module, and it's supposed to land on the surface of the moon. And it can actually land on the surface if its velocity is 3 meters per second or less. So we want to find out what is the greatest height at which the pilot, this height at which you should shut off the engine, that it can land safely under those conditions. So we'll have the subscript 1, which refers to the location where engine is shut off, and 2, the location on the surface of moon. And upward direction is positive, and we're going to apply conservation of energy. So we have V1 is equals to 0 at this location. We have Y1 is equals to h. And at this location, to land safely, your velocity should be 3 meters per second, and the height is 0. So at these two locations, we'll have E1 is equals to E2. So again, we have half m V1 squared plus mg Y1 should be equals to half m V2 squared plus mg Y2. The total energy at these two locations should be the same. So we have mgh, because this velocity is 0, equals on the right hand side half mv2 squared, because y2 is 0 here. So if you solve that, you will get h is equals to v2 squared by 2g, and that should give you 2.8 meters. The pilot should shut off the engine for it to land safely at 3 meters per second. All right, for the B part of the problem, we need to find we have the same conditions, except we have the V1 is negative 2 meters per second. So now again we'll write E1 is equals to E2, and we have half m V1 squared plus mg Y1 is equals to half m V2 squared plus mg Y2. So half m V1 squared plus mg Y1 should be equals to half m V2 squared, because this is the landing Y2, and the velocity at this location now is not 0, but it is negative 2 meters per second. So if you solve that, you will get h is equals to V2 squared minus V1 squared divided by 2g. Rearranging the equations, so you'll get 3 minus 2 squared divided by 2 times 1.62 is the value of g on the surface. That should give you 1.5 meters. So that is the answer to the B part. And for the C part, we have the same conditions, except now V1 is 2 meters per second. So we'll use the same equations. In this case, we'll have half m V1 squared plus mg Y1 is equals to half m V2 squared. So again, we get the same thing, V2 squared minus V1 squared by 2g. We get 3 minus 2 squared divided by 2 times 1.62. Sorry, this is positive. Should give you 1.5 meters. So in this case also the answer is 1.5 meters.